Howdy, everyone. Happy Friday and happy, lovely Texas spring day. Most of you are familiar with Venus flytraps that are supposed to be able to eat flies. Um, when I started college, I still had a girlfriend in high school, and she mailed me a little Venus flytrap plant. And I and my roommates nurtured it for some time, gave it water, but after a while decided it ought to have something to eat. So one of my roommates swatted a fly and we fed it to the Venus flytrap, and sadly it immediately died. So we couldn't prove that they actually eat flies as such. In any case, on Monday, we'll have our second exam. It'll start at 1:25, and you need to turn it in by 2:40. It'll be available on eCampus right at 1:25, and I will also send out the exam by Tamu Direct, but that can sometimes be a little bit slower. So please study and do well on Monday. Okay, as I promised you, I would tell you about global warming today. And so just a reminder, well, actually, let's go back here. So just this reminder of what a spectrum of air looks like. So this is the infrared region that you'd run in a typical spectrometer like an organic lab. Absorption is towards the left. And so when the absorption goes down, it means that those particular wave numbers, those frequencies, very little light gets through the atmosphere. Instead, it gets absorbed by either water molecules or CO2, or in some cases, a little bit of ozone, as we can see. So you can see a lot of the heat that's trying to go through these molecules gets absorbed. So if we go back to this diagram, we have the sunshine heating the Earth. The Earth gets warm, the heat tries to rise up, the atmosphere is full of carbon dioxide and water and some methane. Those molecules absorb the light, and then they re-emit the light, and about half of it is re-emitted back in the direction of the Earth. That which is still trying to escape the Earth will hit some more CO2 molecules. Again, it'll be absorbed and emitted back to Earth. So the net effect of what we have, as I've said before, is the Earth is about 15 degrees centigrade warmer than it would be if we didn't have this greenhouse effect, this global warming effect taking place. But what we're concerned about now is that we've had an increase of more than a degree above that. And even worse, we're worried about the average temperature of the world going up 3 or 4, maybe even 8 degrees by the end of the century. So write yourself a note and make yourself a prediction of what the temperature of the Earth is going to be in 50 years, and let's see how we do on that. Okay, so what I want to tell you about today, or what I wanted to show you today, are slides from Lonnie Thompson. He's a university distinguished professor at Ohio State. He's a member of the National Academy of Sciences, very prestigious organization. In 2007, he came to Texas A&M and delivered a week's worth of lectures, the University Lecture Series that most of you are familiar with. A couple of years after that, in 2009, I organized a conference for the Humboldt Foundation, and we had about 200 eminent scientists from around the country in all areas come to discuss. Well, the title of the conference was The Universe and the World Around Us. So the universe part, we talked about galaxies and the expanding universe and so on. But the world around us, we talked about oceans, we talked about bacterial infections, but one big aspect was global warming. So this is already back 12 years ago. And so I got to know Lonnie Thompson quite well, and he kindly provided me with a set of his slides. This set of talks was given, as you can see, at the University of California, San Diego, about 13 years ago. So I've left out some of the less relevant slides, and I've added a few others, but Lonnie Thompson is basically a glaciologist. They study glaciers. They can look back thousands of years, look to see how much carbon dioxide was in the atmosphere at the time, and methane, and lots of other things, as we'll see. Okay, so anyway, this is his talk. He's going to talk about climate change. And let me just mention, climate change is not a political issue. Fortunately, in the last 10 or so years after this talk, people are becoming more and more aware of it. 20 years ago, people were less concerned, but we're seeing much more clearly now what the effects of it are. And so Lonnie Thompson's a glaciologist, and so he studies glaciers, and what we'll see are there are quite a lot of warming glaciers around the world. If I forget to tell you, among other things, glaciers are very important for producing rivers. So in Asia and India, we have the, the Indus and Ganges rivers. They both come from melt from the Himalayas. If the glaciers have melted, these rivers are going to get to be less and less, and people will have less water. So already in 2009, Lonnie Thompson's going to show some evidence for abrupt climate change, and he's going to show that this is accelerating. I have a few slides I've added that maybe will show more of this accelerations. So, and then at the end, we have our choices. We can try to prevent it, we can adapt to it, or we can suffer. And all of these are real possibilities that may come to be. Okay, so here's a 2009 chart of global temperature changes. Now, the global temperature deniers may sometimes say, well, look here, from about 1940 to 1960, the average temperature didn't increase at all. So as these slides are going to show you, there are other things other than just increasing concentrations of global warming gases that increase the temperature, sun activity, stuff like that. So one has to look at long periods of time. But you can see over this range from down here to up here, it's about a 1 degree change. the last 10 years, I think we've added another few tenths of temperature increases. This is one I added. This goes up to 2020. So here is, again, the temperature increase. So Lonnie Thompson's chart ended here, but you can see we have a steady increase here. So this curve is smoother because it's an 11-year average. We still have that kind of flat area in between. And also relevant on this is solar irradiance. And so, in other words, this is how much energy the sun is hitting on the earth. And so we see we're getting the temperature change despite the fact that the sun has been producing less energy hitting the earth. Okay, so here's some natural mechanisms that influence climate. Also, I think all of you remember from world history that we had ice ages. I think the last one ended 10,000 years ago. And then we could have big, long cooling periods. And these could be natural phenomena that could do it. And on the chart that I showed you before, changes in the sun, solar radiance and stuff, which we can measure quite readily now, some of that's going to affect temperatures. Other things you might not think about is volcanic activity. I've forgotten the year now, something like 10 years ago, there was a huge volcano eruption in Indonesia, I believe, and there was particulate clouds all around. You might think that this actually would warm the earth, but it actually tends to cool it because if you have particulates in the air, then a lot of that, the particulates reflect off the sunlight and less gets to the earth itself. So early in the days when scientists were predicting warming models on the atmosphere, they were getting some of that wrong because they were forgetting to take into account that the particulates do matter. There's more, you get more reflection and less warming of the earth. And then this third part, I'm not sure I really understand, the internal variability of the coupled atmosphere-ocean system, monsoon systems, et cetera, et cetera. One thing to keep in mind, we're kind of focusing on carbon dioxide warming the earth, but the more warming we get from more carbon dioxide, the other main contributor to global warming is water. If the oceans get warmer, there's going to be more water vapor in the atmosphere, and we get even further warming from that. Okay, this is, again, back to Lonnie Thompson's slide. This stops again in the year 2000 or 2009 or so on. This is taken in Hawaii. These are actual measurements, and you can see there's even yearly fluctuations that you have from spring to fall to summer and so on. But also, he has measurements from the ice cores, and I guess this goes back to 1860. So they dig into glaciers, they look at different layers. Most of you are familiar with how there's strata in rock formations. It's similar in glaciers. So they can pretty well document how much CO2 there was at any particular year. And you can see it works out well. They match up well when these measurements started in 1960. Okay, this is my update to his data. So the purple or violet, this is parts per million of CO2. And the blue, I'm blocking it with my stuff. This corresponds to carbon dioxide emissions in billions of tons per year. So a lot of it, of course, comes from automobiles, factories, creation of coal burning by utilities and so on. And so you can see this is more or less as expected. So early on, you can see the CO2 concentration was quite flat. In the 1800s, as you all know, the Industrial Revolution started. We started having railroad trains burning coal and stuff like that. But it's only when really automobiles kicked in the early 1900s that this started rising. And of course, population increases have been pretty dramatic. When I was your age, the world had about 2 billion people, and now it's closing in on 8 billion people. So at the end of your lives, I don't know how many people there are going to be on Earth, but maybe 20 billion. And people are consumers, and a lot of that creates CO2. Okay, so we're going to start looking at glaciers. I mentioned that glaciers have strata, and so you can see there's different layers laid down in different years and stuff, and they can go very deep in these layers and uh, time these by looking probably at carbon 14 in there. And so this is what they're going to be looking at. So this gets more technical in the stuff. They look at ice cores, and they provide multiple lines of climate and environmental evidence, and they're ideal for revealing rapid climate changes as things happen. So they can look at all of this stuff. Dust in the atmosphere, they can go back and see when they have volcanic eruptions, as mentioned here, and so on. Okay, so here's his laboratory at Ohio State. So they have to keep parts of it pretty cold. They bring back samples from around the entire planet, and then they analyze them in these laboratories. Okay, here are some measurements of both methane and CO2. And maybe I need to make this a little smaller. Uh, this goes back now thousands of years. So this is 400,000 years ago, I guess. And you can see there's fluctuation in the amount of CO2 in blue and in methane. And then now here, this is what we might call the modern era, starting with the terrestrial revolution. And you can see how it's just taking off like crazy. When Lonnie Thompson gave this talk, the CO2 level was 385 parts per million. That means 0.0385%, or it's less than 0.04%. So you wouldn't think that it would do that much. But if you think back to that first slide I showed you, look at this one again. This is what you get from 0.04% of CO2 in the air. And if you keep increasing it, then these absorptions are going to broaden and get even more temperature change. Okay, so here is their assessment of what might happen by the year 2100. There are newer assessments, and I think I have a slide for showing that to you. But this shows that a reasonable guesstimate for the change in temperature might be here somewhere from like 2 to 5 degrees centigrade, and that would really have tremendous effects when we look at already what the 1 to 1.5 degrees that we've already had has done. Okay, here's places where they make, measurements. Here's Greenland, obviously, pretty picture. Antarctica, pretty picture. You can see there's a lot of ice. If I forget to tell you, you would know this if you think back about what you learned in physics and chemistry. In the Arctic, if you have ice floating in the oceans melting, it doesn't raise the level of the oceans. But Antarctica is a continent, and most of that ice is on land. And so when it melts, it does raise water levels around the globe. Here you can see some preliminary showings of how they make their measurements. They have to climb to the top of the glaciers, dig way down. They burden some poor pack animals having to carry their equipment and so on. Climbing up to a glacier. Here's how they do their drilling. So for many Texans, this kind of looks familiar. You look for oil. way under the ground. These guys go, uh, I don't know exactly how far, I've forgotten, but I think it certainly hundreds and maybe even something like 1,000 meters that they can go down and get these ice core measurements. Okay, so a lot of their work they've done in the Andes in South America. And so this is part of the areas. Here is one of the glaciers, Cuelcaya, I guess. And here's another one. And here's where they go, they camp out, and then they go on top of the glaciers. Now I'll be showing you pictures of glaciers years back and then the way they are now. Much of this area that's all barren right now, probably 30, 40 years ago, was all totally covered and packed with ice, but it has all melted. But we'll see that in later pictures. Some interesting things, they find insects, and later we'll see a human. This goes back uh, uh, more than 1,300 years. Uh, Here's their crews going in, so it's not all science. A lot of it is just kind of hard labor and hard work, and poor animals have to deal along with it. I'm sure they hire a lot of local people to try to help with these. Okay, so here's again a picture of annual layers. This is that ice cap in Peru that they looked at. Here's their crew, all parked up. Okay, so here's some examples of melting glaciers. Some others may be more dramatic as we go along. This is in Alaska, so notice this range comes up to here, and so you can see a big chunk of that has melted in 45 years in this period right there. This, I think, is one of the more dramatic examples. I think I put a black and white picture into your lecture notes. But this is solid ice, the Muir Glacier, and now it's a beautiful lake, but you can see clearly that this is melted. All of you, I think, also remember from chemistry or physics, it takes 1 calorie to increase the temperature of water by 1 degree centigrade. But it takes 80 calories to go from 32 degree or 0 degree centigrade ice to 0 degree centigrade water. So it takes quite a lot of energy to melt a lake like this. Okay, I have a chat comment. Some people are finding this sad. Well, it's a beautiful picture, but if you think of the ramifications of what's going on, it is indeed pretty sad. So this is over a 63-year period. Obviously, back in 1941, people didn't necessarily think about trying to track global warming so much. And so it's lucky when you can take pictures that are pretty much in the same place. So this is a black and white picture, and then a more modern picture 40 some years later. Here's some others. Here are the Himalayas. As I mentioned, the Himalayas glaciers are important for forming the Ganges River and the Indus River. And people in India not only get their drinking water from it, they wash their clothes in it, and they're very much dependent on it. So 1978, 1998, I don't see a data on this one, but you can see just a whole lot of it is gone. There used to be ice up to here, so you can see it was, to me, it looks like 40 feet deep at least that the ice was, and a lot of that has melted, and we now have a pool of water down here. This one, there's just a drawing of where things are. This would be probably 2009 or 2008, whenever Lonnie Thompson's people were out here. They go back and look at records. Then in 2002, it was down to there. And probably if you went back another 20, 30, 40 years, this lake was probably all a glacier. Oh, okay. That takes care of that. I didn't have to try to explain that. So go back to 1957, that was all a glacier. Uh, One reason I like to show this set of pictures to you is, as we always say, pictures worth 1,000 words. And if you can visualize what's happening, I think you understand a lot better than our telling you that the CO2 concentrations have gone up from 380 parts per million to 420 parts per million. When you can actually see the effects of it, I think it's more dramatic. Okay, so they obviously went here. And again, that's probably what was around in 2008 period of time. Here are more pictures. Um, Here is Glacier National Park in 1910, and looking at what's called the Grinnell Glacier in 1998. Uh, I was there probably in about 2009, and you almost wind up wondering, why is it called Glacier National Park? There's not very much there. Uh, you can see here from 1932 to 1988, pretty much all the glaciers are gone. Just north of Glacier National Park are two Canadian parks, Banff and Jasper National Parks, which I've been lucky to be able to go to twice. The first time was in the mid 1990s, and I rented a car and drove along the glaciers. And there's a glacier everybody walks on. There was a big Mammoth Glacier. Then I went back about 20 years later, and over half that glacier was gone. So I can confirm personally just what is happening. Ethan says Banff is gorgeous. It absolutely is. Banff, I think, is more gorgeous than Jasper, but they're both absolutely gorgeous. Jasper is more known for its glaciers, as you can drive along them on a nice highway. So British Columbia is a beautiful part of this continent. Okay, Sarah went to Glacier National Park in 2018 and said she saw only one glacier. Uh, Maybe they're going to change the name and call it Former Glacier National Park. Anyway, you can dramatically see the effect of what's going on. Okay, since we're talking about something norte, this must be back in the Andes again. Uh, Let me shrink the screen, see if the dates are on there. I don't see the date, but this is 2001, but you can see it disappearing. Kilimanjaro, Africa. In the 1950s, when I was growing up, there used to be lots and lots of movies made in Africa, Tarzan, and people going on safaris and things like that. And one of the highlights of the movies was you could always see a picture of Mount Kilimanjaro in the middle of hot Africa, and it would have this beautiful snow cover on it. And you can see what's been happening there to Kilimanjaro. And so here's the aerial photo of 2000, and you can see it's just patches of snow or glacier as you look at it. Okay. Okay, again, just more of a picture of Kilimanjaro. So they've studied all of that, and they can see the melting of different parts that you have. So some recordings of outbursts of water. So these glaciers wind up collapsing and then melting. I guess that's a cute inverted icicle. And here's where they go into the real cold stuff. And again, they go really into the drilling stuff. They take these cores back to Ohio State and analyzed them there. Here's an example of an ice core. They selectively pick a certain region and they have to carefully label it and keep track of it. Here are their people carrying off the ice cores on their backs. And this is a poor creature we saw before. Here's a bigger animal for it. Who knows what this animal is called? Send a chat. It's a yeti or a yak. I don't know. Somebody calls it a hairy donkey. I don't think that's what the Peruvians call it, or an ice cow. Anyway, we could give it lots of names. Okay, so most of you probably know the Andes is the longest mountain range in the world. Goes from the very tip of northern South America to the very southern tip, where you have Patagonia, south of Argentina. I've never made it to Patagonia, but I've had several nice trips to Argentina. And very interesting country, actually very much like Texas. They have real cowboys and kind of dry areas and stuff like that. Anyway, enough about Argentina. Okay, so presumably we're now going to start looking at specific ice caps. We've looked at the Quelcaya one before. Here are more pictures. I think we saw different variants of this picture before. No lake, total lake. This is just a matter of 26 years, lots of melting. And notice also it's not just a matter it's a lake, but if you look at the sides, the ice level was probably pretty high up. So I can't guess whether it was 10 feet or 40 feet, but a lot of ice anyway has melted. Okay, here's a blow up of that lake area. 2006, lake was 84 acres. And here's the retreat that they have tracked. So 1963, 78, and you can see by 2006, there's practically nothing left. And here are some visual pictures that they've done for this thing. Okay, here, notice all the ice around here. We're going to look at a boulder, and the next slide will show the region around this boulder. And there it is, and you can see most of the ice has disappeared. It'd be fun to see if Lonnie Thompson has updated these slides, and maybe all of this ice here is gone already. Lonnie may actually be retired at this point, but I hope other people have taken over his work. There's that boulder again in the lake, and very little ice left there. One thing that Lonnie Thompson liked to talk about, glaciers probably suffer more from warming than at lower altitudes. They're more sensitive to temperature changes, and sometimes you get larger trends at higher elevations. And so I think that's kind of what is shown here, that I'm not sure what the number of stations count is, but this is a trend in degrees centigrade per decade that you have. So this would mean in 100 years, you'd get something like a 3.5 degree temperature change. Okay, so here are other spots I've gone to. Here is the Himalayas in probably Nepal, north of India. And this would be Kilimanjaro in Africa. These are the Andes that we're looking at here. And I'm not quite sure where this is. Okay, so towards the end of the talk, you might wind up calling this preachy, but Lonnie Thompson always wants to make sure that his audience gets the message. And I think most of you are familiar with the story about having a canary in a coal mine as a warner of what might be going on. So humans can maybe tolerate changes or bad air better than a canary. So if you have a canary in a coal mine and it croaks off, it's time for the humans to get out of there. So he's pointing out here that glaciers are more sensitive to climate change, and so they're a good forewarning of what to be careful about. This other comment here is global glacial retreat at the beginning of the 21st century is driven mainly by increasing temperature, although regional factors, deforestation may also play a role. Okay, so you can see this guy is concerned about what is happening in his glaciers, or he would be if he knew what would be happening with his glaciers. So this same region again, lots more snow here, lots less snow here. Peru. Uh, the next couple of slides shows some things that they found uh, in their ice cores. Here's a picture of a plant that they found. And so they found what it was. Uh, I think BP refers to BC in our normal stuff. So this would be probably 7,000 years ago. Modern, it's like that. So one can do some nice botany studies by looking at glaciers also. And you can run across humans also. So I'm sure people have gone after the DNA in this Tyrolean iceman. The Tyrolean part means it would be in southern Europe as such. After Lonnie Thompson gave his talk, there's been a lot in the news about Antarctica. And I think I may have stuck something in your notes, in the lecture notes about Antarctica breakups and so on. But as the statement says here, people worry about breakup of the ice shelves on Antarctica. These are more clear indications of the effect of global warming. Also, this is where we might get most of the rise in the elevation of the oceans as such. So here's Antarctica, and so they're on this ice shelf. This is the Antarctic Peninsula, jetting out here on the left, and so this shows regions where ice has melted. And I think some more of this part has broken off in the last 10 or 12 years or so. Here are some pictures of the collapse of some of the ice over a short period of time, obviously called the Larsen B ice shelf. Whoops. Okay, some more pictures of Antarctica. Noting here, this is what I said before, floating ice shelves do not contribute to sea level rise. But when you have ice melting off a landmass, then it's going to increase the overall depth of the oceans. Now he switched to the Arctic and Greenland. Here he has some quantitative measurements. Greenland is gaining mass at the higher elevation, more rain, but losing mass along the coast. So on the whole, it's losing some annually, and Greenland also being land, any ice melting from that can increase ocean depths. Here are some numerical data, which I'm sure has been updated in the last decade, of how much mass is being lost compared to the entire mass of the Earth. It's maybe hard to measure, but 204 gigatons annually. We all know about giga from gigabytes in memory. So a gigaton is quite a lot of ice melting. And then if we have 204 that we might be losing, that's quite a lot. Okay, so here are some of the places that they've studied. This was the Antarctica part. So this is Chile, Andes. This is Peru, Ecuador, and so on. This is southern, uh, well, I'm not sure. I was going to say southern Alaska, but it could also be around where Mount Rainier is, and Mount Hood in Oregon and Washington, Greenland, Newfoundland, north of that area, Kilimanjaro, then the Himalayas. Uh, the green part shows where 70% of the world population is. And this kind of helps reiterate what I said about glaciers being needed for rivers. So India, with 1.2 or 1.3 million, billion people, needs all the water it can get out here. Uh, and if the Himalayas dry up, there's going to be deep problems. Water, of course, is also needed for agricultural production. Okay, so here's numerical data, sea level back in 2008 when this talk was made. Currently rising at, that's about an inch and a quarter per year. So that doesn't sound like a lot, but that comes out to be a foot per decade. And as I'll show you in some other pictures, if you go 3 or 4 decades, 4 feet of elevation is going to put some areas of the world underwater that were not before. In fact, these are the pictures. So these are from a fellow named Dan Schrag at uh, Harvard. This is a current picture of, not a current, but 2008 or whatever picture of the United States in its greenery and its coast. And here's the estimate. And unfortunately, I don't have the date for this, but let me go back. Here's Florida. This might be in 2050 or maybe even 2100. A lot of Florida, the Key West, the islands, a lot of those are going to be below sea level when we get to that point. Maddie says it's scary. Um, this is even more scary. Hopefully, everybody recognizes this, or maybe I shouldn't say hopefully. Uh, One of the Aggie lady basketball players, who was a big hero a few days ago, is from here. This is New York City. This is Manhattan. Here's New Jersey. Bronx and Brooklyn are over here somewhere. And so here's what happens to Manhattan and the rest of New York. A lot of it is underwater. Another chat comment. People want to see what happens to Florida again, so let me show you that. Okay, so actually take a look at Louisiana here too. A lot of that has disappeared. So New Orleans, of course, is already under sea level. Uh, but again, sorry, I don't have the dates for these projections. And of course, the projections are dependent on what we as a planet actually do in the next century, I guess is fair to say. Someone says, I bet Houston would be affected. Uh, yeah, it gets affected enough just by its rainstorms. And I'm sure Galveston would be partly affected. It's not on this particular map right here, but there are things to worry about. Okay, so again, look at New York. Nice little, I think this must be the Hudson River coming in. Nice tunnels going under the river. But what do you do there when you have this situation? So this winds up being the bottom line then for Lonnie Thompson. There are three options. He mentioned these at the beginning. Number one is prevention. You students in this class are chemical engineers. So my fond hope is that one or some of you will find a way to easily eliminate carbon dioxide from the atmosphere. That would be great. The fact that there is so little of it, but has such a big effect, makes it very difficult. When you try to remove 0.04%, oftentimes you're going to use so much energy to remove that CO2 that you'll actually generate more CO2 in the process. So people know of catalysts and things like that that can remove the CO2, but something feasible that could turn CO2 back into something more usable would be really good. Uh, I don't know if I mentioned this before, but carbon dioxide lasts about 100 years. So whatever is produced, and hopefully you're not driving a big maroon Aggie pickup truck that gets 10 miles per gallon. When you're putting that CO2 in the air, it's still going to be there about 100 years later. So it's very hard to reduce emissions or reduce the amount of CO2 in the air unless we get a balance that the CO2 itself falling apart gets to be a quicker rate than uh, what it's being produced at. Okay, we have some comments. Have people proposed increasing the Earth's albedo to counteract the greenhouse effect? That could be more dangerous than something else. Uh, Someone else says plant all the trees, but I think they mean trees we consume without replacing. That would help, of course. Someone else says we need to use more algae. I've actually had collaboration with a biochemist at A&M. We take Raman spectra of the oils produced by algae. The algae take up CO2 and they turn it into usable oil. So people are trying to do that more effectively. Someone says, isn't that what Bill Gates is planning on doing? Yes, I'm glad people are keeping track of what efforts are being done around. But it's very much of a challenge to just find a perfect way. Okay, possibility two is adaptation. So we don't necessarily have to have Manhattan underwater and Florida underwater. I think all of you are familiar with the Netherlands, Holland. There's this nice story about uh, this young boy sticking a finger in a dike, and so the whole country didn't get flooded because virtually half, I think, of Holland is under water. Just the word Netherlands means it's underwater. In German, it's Niederländer, or again, the lowlands or underwater regions that you have. So the Dutch have adapted to that. They have cities in that region, but I guess if I lived in Holland and the ocean were rising even further, I would also worry more about what may actually have to be done to maintain these things. Some more chat comments. Uh, Someone is mentioning Venice. Yes, Venice is sinking. It doesn't help that the water levels are going up. I haven't seen the latest, but there's a big effort uh, by the United Nations and others trying to save Venice for what's happening there. And Ava thought that Holland was more like 2/3 of the country. It's a big chunk, so I don't really know what it is, but I've seen pictures. Okay, last choice is suffering. Obviously, if the Ganges River in India dries up, if you live in a part of Florida that winds up being 2 feet underwater, you're not going to be very happy with it. If you like to vacation in the Maldives Islands, I think their elevation is just a few feet above sea level. Uh, Basically, you're going to have suffering. So these are really major effects that one has to think about. Another chat comment. Uh, Someone says most of the world has picked suffering, uh, and that's how this has become a political issue. So, uh, if nothing else out of this lecture, remember this slide and remember my pictures of the melting glaciers. If you see somebody who says, well, I don't really believe in global warming, if you can show them any two of those pictures, you can't not believe in global warming when you see what CO2 absorption does. And then when you look at the pictures of the glaciers uh, melting. Okay, so this is the suffering image to create empathy for people of the world. And so his summary. Uh, I think most of you, despite our record low temperatures this winter in Texas, most of you have seen the information that almost every year around the world winds up being the warmest in recorded history. And so it seems to go back, I guess, here 5,000 years. So we can make these measurements. And if you want to be a denier, people can say, well, we have fluctuations from this or that, but just one should look at the facts. So they looked at a lot of ice cores, they generated a lot of information, and I think even just as importantly, they've produced a lot of pictures that can be shown to people who are not concerned about this. This I mentioned several times, but it's very important. Glaciers in most part of the world are rapidly melting. There will be loss affect 2 to 3 billion people, and valuable paleoclimate archives will be lost forever. Not only that, but rivers may disappear. So glaciers are the most visible evidence of global warming. They have no political agenda, but they do give us a message of what is happening. Uh, Someone asked how much of global warming is a result of human activities versus the natural warming cycles of the Earth. I try to address that, or Lonnie Thompson did at the beginning. There are natural cycles that happen, but if you look at the direct correlation of CO2 increase, some methane increase, it's a direct relationship. Also, that one chart that I showed you in the beginning, even when solar activity went down, the temperature at the Earth went up, and that was corresponding to the CO2 levels. So people can get off on tangents. They can talk about cows and the cows producing methane in the air, and maybe we should get rid of the cattle industry. But that's even human extent, some extent. But the biggest thing is just simply the consumption of fossil fuels. And actually, my message to chemical engineers is at some point, fossil fuels are going to run out. They're lasting longer than people expected. But if it all gets burned up in automobiles, then there's going to be less for making, I'll call them plastics, but polymer desks. If you look around, so much of what used to be made of metal is now made of sturdy polymers that are based on hydrocarbons that we get from oils and so on. So just for your own livelihood, it's good if you can get people to quit wasting gasoline in cars. I have 2 daughters in California, and the 2 families, between the 2 of them, they own 3 Teslas, which are the electric cars. And I don't know the exact statistic, but at least in the Northern California area where they live, it seems every other car is an electric car. And so California is often ahead of people with that kind of stuff. And things are like that. Things like that are things that one has to consider doing to make it go. Someone else says breaking: humans run around the galaxy, ruining all habitable planets and never learning from their mistakes. That's only if we can find wormholes and go faster than the speed of light and get somewhere else. So unfortunately, as much as I love astrophysics and astronomy, I think the chances of ever making contact with another civilization in real time is minimal. We might get a message from somebody that was sent a million years ago or something, but we don't know. Someone else is saying, should we join Elon Musk and go to Mars? Well, things could happen in the 21st century that maybe there could be things set up on Mars. I don't think there's going to be a global warming problem. Incidentally, if you didn't know, uh, Venus has a tremendous greenhouse effect. And so it's got a murky, thick atmosphere hydro, uh, full of sulfuric acid and everything else. And so there's too much greenhouse effect there. And that's why one doesn't anticipate there could possibly be any life there. Okay, so here's some measures of global melt. And then this is often a picture that environmentalists like to show. This is the only rock we have to live on. This must be North America. That looks like South America. Looks like storms coming in. But anyway, I hope Lonnie Thompson's slides left you with an impression of something to remember. Yeah, somebody is saying, isn't class over? And you're free to go. Hope you found this worthwhile. And someone else says nuclear, wind, and solar. I'm a big proponent of nuclear energy. It's been unfortunately misunderstood and poo-pooed by people who think they're trying to save us all from nuclear holocausts. But a lot less harm, I think, comes from nuclear energy than almost anything else, except possibly solar or wind. Someone says there are 3 more global warming slides. Okay, thank you for pointing that out. Here's some of the investments that one can make in. I don't know how many of us are willing to give up a car or fly less. So a lot of us like our conveniences, but there are ways that we can help. So this is a good one to end on. So I show this to your friends who might not, or who might still be skeptics about global warming. Someone suggesting nuclear planes. From nuclear, you can get energy, but how do you get propulsion? You need some kind of mass. So you'd have to compress the air with your nuclear power and then blow it out, compressed something. So all things are possible. So most of you have many decades ahead of you to try to make things better. Okay, so we'll see you on Monday for the exam. And if you feel like, tell me what you thought of this presentation, whether it was worth showing. Okay, you all take care.